so much for joining our webinar this evening in the UK with Debbie Roberts, who will be focusing on our Mission Science series and focusing on our resource, the series, some of the key aspects of the series itself, and also you will have an opportunity to ask any questions towards the end of the session. As always, if you have any questions, feel free to write them in the chat box and we will do our best to answer your questions. I'll pass it over to Debbie now. Thank you.
Hi everyone, welcome. Good to be here with you all, and thank you so much for using your precious time to attend this webinar. So let's get cracking. So this is our meet and greet for the 27th of January, and this is a little bit about me. So yes, I was one of the co-authors of Mission Science for the first edition, and for the second edition I was a little bit more proactive and made quite a few decisions, moved things around, brought it a little bit more up to date. And so I'm really proud to be here and talking to you about the second edition of Mission Science. I'm a published author, and just over the last few days I have gone over 100 publications, which I'm really proud of. I'm quite shocked and stunned that it's over 100 publications, and I'm very fortunate that near enough everything I've written has been published, which is a fantastic honour and a compliment. I'm also an educational consultant, so I work with lots of governments and ministries and around the globe. I'm also a trainer. I train lots of teacher trainers, and I've also worked in teacher training, so I've trained lots of trainee teachers as well as a professional mentor, professional tutor, and also as a science specialist. I also train people in computer science, and I'm very privileged to be able to do that, and I think I've brought a lot of that into this second edition also. So we will be focusing on Mission Science, and some of you will be very familiar with it, using it already in your schools. Some of you might be considering using Mission Science, and some of you might not know anything about it. But it's good because it's based on the OECS standards, and so it can be used as a really valuable resource if you're working with the OECS standards. So let's have a look a little bit further. When we were planning the second edition, I was very lucky because I don't know if some of you know me that are with us this evening. If you do, hello, good to see you all again. I do get some emails from some people, and I do get some really nice emails and compliments about the work that we've done together in the past. I have been very fortunate to come out into the Caribbean, into schools, into universities, and worked with lots of people out there. And I think that's why the Mission Science works so well, because it's part of you, the people who actually contributed to it, gave us ideas, told us what you liked and what you didn't like, and we were fortunate to keep in what was good, update what wasn't so good, and we got rid of some things. So I can see some names of people that I recognise, so hello and welcome back. So this scope and sequence as a teacher, I really like, because often we get, as teachers, lots of really useful resources, but the problem is we're so busy that we don't really have time to look into them into great detail and to use them fully. And that's a shame, really, but it is true. This scope and sequence, for me, I like it because everything's there. It's all laid out nice and simple, and everything's in one place. I don't have to go looking around and trying to find things. It's just really useful. And even if you're not using OECS standards and you're using something else, you can actually use this to think, oh yeah, that objective's covered, that objective's covered there. And it gives you so much confidence in teaching and planning because you know that you've covered everything that's important. What's new? Well, we've introduced some things like we've got icons for the life science, earth and space science, and physical science. These are in line with OECS. But also, I think it's important that we begin to separate out science into different areas, because we want our students to start thinking about different aspects of science and to understand that there is a difference. Often we get students who are coming into higher education, they don't really understand what physical science is, for example. And we want them to make selections and choices based on facts. Well, what's the intention of the second edition? We've kept some of the great features, and the great features for me were always the opening pages of each unit. I was concerned in the early days of the first edition when I saw that we were giving up a double page spread to an introduction, really, to learning. And I was a bit skeptical, but when I came out and I saw how teachers were using these resources and using these pages, that I thought, yeah, these really work. I like the idea that it kind of explains, it gives students a reason. This is what we will be learning. This is what we will be learning about over the next unit. It acts as a stimulus. And in inquiry-based learning, the stimulus really is the most important part of learning, because this is what engages children. This is what enthuses them to want to learn more. It makes them curious, begin to ask questions. It's a good, grounded introduction to the learning that will take place over that whole unit. And it's absolutely based on inquiry-based learning and teaching. I am an inquiry-based lead, and I'm proud to say that. I've worked hard to call myself that. But every single resource, every book that I've ever written, and every project that I've ever been involved in, I make sure it's inquiry-based learning and teaching. Please note I say inquiry-based learning and teaching, because learning comes first for me. Teaching is second. Learning is the important part. Doesn't matter how good you are at teaching, if the students aren't learning, then it's pointless, because it is all about learning for me. And everything I've ever done is based around inquiry-based learning. What does that mean, just in a very short nutshell? Why have I decided that everything I've produced should be around inquiry-based learning? And that is because it develops skills, and these skills are life skills. We as educators should be preparing our students for the next stage. If we're primary teachers, we're preparing our students for the next phase in their education. If we're university lecturers, we're preparing the students for the workplace. We're always thinking about the next step. As primary school teachers, you cannot think about the final outcome. You might look at your students and think, oh, they're really good with technology. They're fantastic at investigative skills. But we can't really prepare them for the final stage because we don't know what it is. Technology and science is moving at an incredible pace at the moment, and we have no idea what the world will look like. I remember a few years ago looking at what looked like a desk with a massive TV screen laid on it. And I remember looking at, and they were telling me that this will be an interactive operation of a human body, and that they'll be able to touch screen and move things around. And I thought, no way. And yet here it is. We have that now really on our mobile phone. On my smartphone, I've got an app where I can dissect the human body on my phone. So technology is moving at a massive pace. We've got challenges, investigations, research opportunities, all the important things that we need to prepare our students for the next stage. So the unit opener for me as an inquiry-based teacher and educator is the opening pages. So these act as an introduction. They're engaging, they're stimulating. We've updated these and upgraded them and changed them. And the artwork, I think, I'm not very good at art. No, I'll rephrase that. I'm rubbish at art. But the artwork is phenomenal. And the feedback that we've had from it is really, really good. They're full of engaging and stimulating images, and so you can use these to get students thinking to straight away at the beginning of the unit. What am I learning about? Why am I learning it? Why is it important? We're using the real world science to show students the importance of learning science. It's not about you have to learn it because you need to pass the exam. It's not about that anymore. We're learning science because it's important. We're separating it into 3 sections of science. We're using symbols so that we can quickly identify this unit on structure and function will be about life sciences, because in the top left hand corner I've got the life science symbol. It's got the keywords for the whole unit, so students can decide what they already know and what they need to learn. It's also got the key ideas, what the key principles of what they'll be learning, all in one place on that opening page. These are, for me, really phenomenal and really useful as a teacher. All of the investigations are set out on this graph paper. So if you're just flicking through the book to have a quick look at what we'll be covering in a unit, you can see all the investigations clearly laid out on this graph paper background. All of them are designed to encourage the development of some skills. Skills like taking responsibility for their own learning, being independent learners. It's no one's fault but theirs if they don't understand something. They are stood or sat in front of somebody who's an expert. If they really can't work it out, they need to ask. There's a resource that's readily available for them. The skills they'll be learning are predicting, and this is different to a guess. We've taken out any reference to guesses because it's not about guessing in science. It's about making a prediction based on fact, based on the work of other scientists. And that's leading into formulating an hypothesis. An hypothesis based on scientific evidence, based on research, based on other scientists' ideas. You could well be hypothesizing and investigating things that another scientist has already claimed. Students are expected to start to be able to design and plan their own methods from an early age. If they do that, then they're not just following a bullet pointed or numbered instruction. They're actually beginning to think about how to investigate and how to test a prediction or an hypothesis. Students learn how to record in different ways, using tables of results that they've drawn or that others have drawn for them. Recording results as tables, bar charts, graphs, different kinds of charts, diagrams, photographs, videos, observations that they've made. They evaluate the effectiveness of their method. Why did it work out like that? Note it's never wrong. It's never wrong in science. If it was, we wouldn't have these fantastic discoveries that we've got now. But why did it not work out the way that I thought it would? It's not my fault, and I'm confident to say that. But something changed, something's happened. Why isn't it the result that I thought it would be? And often it's down to human error. It's either the method that's not quite right, or it's not being measured accurately, or it's not being recorded or reported accurately. We can then go back and carry out further research to find out why. Safety is your responsibility because you're responsible for the children in your care. But that doesn't mean that you have to tell them how to behave safely. You need to be aware of any hazards and any risks, and you need to be able to manage them. But if you explain to the students risks and you explain hazards and you discuss how to work with them safely, they become more confident. They follow rules and warnings much better because they have the ability to understand that just because there might be risks and there might be hazards, if you learn how to manage them successfully, it's a safe environment. And in science, we have to work in environments that are not always safe. We use chemicals and equipment in order to test predictions, and that's how science is. But it's about being confident and feeling safe. Students need to know that when they're working as a scientist, they're responsible not only for their own safety, but also the safety of others around them. So they're not just sensible to protect themselves, they know that they need to protect the teacher and to protect everyone who's in the room. And so throughout the book, we have put a stay safe feature, just to highlight the idea that this could be dangerous. You need to think about this and you need to read this information before you continue in order to keep everyone safe when they're carrying out this practical. ICT is really important now. It's important because of blended learning. We need to be conscious of blended learning. It's become more and more and more important during this pandemic. We suddenly were faced with students working from home, working in isolation, working remotely, but yet we still wanted them to learn. And so blended learning became very important. But we designed this feature a long time before we knew about COVID. We realise that ICT is not only important, and it is something that students will have to understand and work with confidently in the future, but it's also something that students really enjoy. If you give students a smartphone or a computer of any description, they will work wonders on it. They're much more proficient and more confident than I am. And so let's use that. Let's utilise that skill in order for students to learn better. So ICT is identified in different places. So here we've got it in the real world science and as a research task. ICT is use this feature in different places, including investigations and activities, where ICT can be used and utilised. It could be research, it could be to communicate ideas. During this pandemic, I've observed students communicating through safe internet use of emails, online platforms, social media that are actually monitored and managed by responsible people such as parents and teachers. It's a great way to communicate ideas, to find out the answers to questions, to carry out research and to problem solve safely. And again, it's a good opportunity to show that science is learned for a purpose, not just to get through an exam, but to actually be used as a skill, a lifelong skill that will last well beyond the learning stage that they're at the moment. In inquiry-based learning, at the heart is always a question, and if that question is actually designed and asked by a student, it becomes, and I'll use this phrase confidently, it becomes powerful. It becomes a powerful tool in learning. The talking points for me are the most important parts, or one of the most important parts of these resources. It encourages children and students to think. It encourages discussion. Students will very confidently talk about aspects of any subject content. If you ask a question, they might not put their hand up and offer an answer. But if they're talking in a group of their friends, they'll often be using quite complex language. They'll communicate that scientific vocabulary quite confidently and quite competently, and they'll learn from each other. How do we learn language as human beings? How do we learn to communicate? We learn it through watching others, through listening. The people that nurtured us as babies, we learn to communicate from them. And we continue to learn from watching and observing others. Many times teachers tell me that the language is far too complicated. It's far too complicated for primary or reception or early years students. Where else will children learn to use the word pollination, germination, photosynthesis, esophagus, electrocution? Where will they learn to use these words and learn what they mean unless we model them? I might have told you this story before, but A few months ago, I was working with some early years student in a laboratory that had been specifically designed for this age group. So there were little tiny stools and goggles and white coats because it had been funded just for this age group as a pilot scheme to see if it actually had any impact on learning. And I'd been given the challenge of teach these students what it means to be sterile. And I was told that they wouldn't understand it at this age group. And so I said, you can't eat the sweets because the environment is not sterile. If you put those sweets near your mouth, those sweets are no longer sterile because they've been on a workbench that's been used for a science investigation. If you use that straw to drink that water, you will make yourself ill potentially because the straw's not sterile. Things in a science laboratory are not sterile. And at the end, a student came over to me and said, you must have said sterile 100 times. And I said, oh, I do apologise. What does sterile mean? And he said, well, quite simply, it means it's not clean. And there you go. He recognised the fact that it had been repeated enough times, but subconsciously had learned what it meant. And so we need to use these talking points and encourage the use of scientific vocabulary to collaborate, to communicate, to discuss their learning, because it's their journey and it's about them. Again, real world science is really important, and we put a lot of effort into trying to find real world science in their world. And Caribbean scientists and scientists that were working in the Caribbean currently. We tried to use as much as we possibly could in the real world science feature. If you come across more up-to-date examples, where scientists are currently working in that field, then use them. Take the opportunity to show students that real science is happening where they live now, and it's being used for a purpose, to find new discoveries, to work on new devices, to work on new technology that will make their everyday life better or different. And it's about the future, not just of the country where they live, the future of the world, the future of the universe is built on the work of real life scientists who are working away now to make science better. So this feature promotes the work of scientists and it raises the profile of science. Science got left behind a little bit recently, over recent years, and it's a shame because unfortunately it's the results of that are showing, and there are less scientists around and less discoveries being made, and science is behind everything. And people say, well, maths is, yeah, well, I see maths and science as the same thing. So really, yeah, they are behind every discovery in the modern world, and I predict every discovery to be made. The challenge feature continues. So that is being included because it's a very important part of differentiation. In science, some people say it's unfortunate because in science we need to learn physics, chemistry, biology. We need to learn maths, and we do learn a lot and use a lot of computing science as well. I see that as a fantastic bonus because we're seeing the world, we're seeing everything that's behind every discovery in one subject area. And it just happens to be that I'm the lucky person in that subject area, as are you. Sometimes what that can mean is that you could have a student who is absolutely flying and loving science and everything's fantastic, and then we switch to something like, I don't know, biology, and suddenly it gets difficult. And so when do we challenge? Who do we challenge? We challenge everyone. We push absolutely every student to the absolute limits of their understanding, and we continue to push because extending knowledge and applying knowledge to new situations, especially the synthesis where students have learnt something and then we take them beyond it. We take them completely beyond the learning objective in this lesson, in this unit. And we ask them to synthesize what they know and what they understand to a completely different challenge, a completely different problem. You've understood this. We've got this problem. How can you find a solution to this problem? By going through that process, we're actually taking the students' understanding to a much, much deeper intellectual level. And when we get to that deep intellectual level, students start to apply their knowledge to new situations, and they become confident, and they become confident problem solvers. And that is the best gift we can give our students now, because we don't know what they'll be faced with in the workplace. But if they are competent and confident problem solvers, they will work out how to get out of things, and they'll figure it out. The science projects are brilliant. Blended learning again. Blended learning has become very topical now because we're suddenly working remotely one minute, back in school the next. I've been through most of the activities in all of the mission science books, but definitely every single project, and all of these projects can be done remotely from home. There aren't any requests for complex resources or anything like that. If any of you attended some of my webinars, you will have seen me actually demonstrate the project here using popsicle sticks, lolly sticks, elastic bands, and tops from soda bottles. And I actually showed how easy it is, and that everything could be collected quite easily and used from home. We've got different ways to do this. Flipping blended learning around, we can flip from face-to-face learning in the classroom to remote learning at home, to computer learning at school when we've got mixed groups who are working at different stages and different levels. And so the projects are brilliant for blended learning opportunities. They encourage students to use their ideas in a new and different way. They showcase the role of science. They encourage students to be creative, imaginative in science. Students are encouraged to work in teams. They might be a team leader, so they're promoting leadership skills, or they might have to work as a team player, and so they become to respect the role of others within that team. Working as a team is one of the best things that we can train students to do, because they will be working in teams with different people doing different things in the next stages of their education, and most certainly in the workplace. It's important that we measure where students' progress is being made, and we support them if progress hasn't been made. So we need to assess our students, and at the end of every unit there's an opportunity called Check Your Learning, where students can answer questions independently with a group. They might want to answer all of the questions as a formative test, or it could be that they answer individual questions at particular times during their learning of the unit, and that's up to you to use them for whatever purpose that meets your school's needs and expectations, and also investors, parents, carers. We're looking at a workbook and the use of workbooks tomorrow, but I wanted to include it here in this webinar because the workbooks are integral with the support with the student books, and they support the learning. Students get opportunities to be challenged further. It might actually give them some support in some of the investigations and the activities. There's also home learning opportunities where parents can get involved and see for themselves how students are learning. They're also a write-on record of their learning at that moment, which becomes a very good revision tool. For every single unit, every single page, every lesson, there is support for teachers in the teacher guide. These show how to set up the equipment, any alternative equipment if you haven't got the resources that you need. It gives alternatives to resources that could be used. Importantly, it highlights misconceptions before you've actually taught the lesson. So you can be aware of misconceptions breeding, and you can nip it in the bud straight away before it's developed and it's been adopted, because at that point you have to unlearn it and then reteach it, and that's not always effective. So let's highlight these misconceptions before they manifest themselves. There's also useful tips on how to manage learning, how to manage groups, how to do activities, investigation. Oh, so question time. I've written some questions down which are based on, I've been doing webinars 2 or 3 times a week for the last, well, year it feels like, really, I guess. And so I've jotted down some questions that I've been asked over the last few webinars. But if you've got any questions, please, 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 please write them in the chat box, and I will try my very, very best to answer them. Whilst you're thinking about that, you might want to read through these questions. If you can't think of anything at the moment, you might select a question that's important to you from there. Please let me know. Otherwise, I'll just carry on working through some of these questions until somebody writes something in the chat box, or until we've used up all our time effectively. So I was asked recently by someone who wasn't using the OECS resources and standards, and they asked me if they could actually use these mission science resources. Yes, you confidently can. Because if you remember that scope and sequence at the beginning, you can actually match that up to whatever standards you're using in your classroom currently. But yes, you can very confidently, these have been matched to other resources and other standards, and you can confidently use these mission science resources to teach any of the standards that you're teaching currently. Still no questions? Okay. So then I was also asked, my students far too young to understand variables, and variables are mentioned in the mission science resources. I agree. Your students probably don't understand what variables are. Why would they? Unless they've been taught what variables are, they won't understand them. So it's our job as educators to introduce students to variables and to encourage them to use variables, because the more that they recognise a variable, the more confident they'll become, and then they'll start to use that terminology themselves. This question comes hand in hand, really, with a fair test, because I was also told lately that primary school children don't understand what a fair test is. As a parent, I beg to differ. As a teacher, I definitely know that they understand what a fair test is. I've got 2 boys and there's only just over a year between them. I know that they understood fair tests from the age of maybe 2 or even below that, because I know that if I'd have given one of my children a bar of chocolate and not the other, they would have said, that's not fair. So yes, they do understand a fair test, and they do understand what it means to be unfair or not fair. And so what we have to do really is use that understanding and transfer it to what we do in science. So if we cut down an investigation into the variables, the independent variable, I am investigating that. I am in control of it. I'm changing that. I am changing the temperature and observing what happens to that material. I am changing the material to find out if all materials are stretchy. I'm measuring what happens. I'm observing when I change the temperature. I am observing what happens to the chocolate. I am observing the dependent variable. The dependent variable changes because it's dependent on what happens to what I change, the independent variable. And so if we take time to break investigations down into variables, children soon become very understanding. As I said earlier, we learn as humans from observing people. And so if you model that, then they will learn it quickly. How can I carry out research with primary children? I think children are very good at research, especially using the internet. They are very proficient. I think we just need to train them that, you know, some information is not always as reliable as others, and practice finding the best source of information, and practice using search engines and things like that. I was also asked, the internet where I am is intermittent, and the internet where I'm is intermittent as well, because now all of a sudden everyone's working from home, and so there's a massive big demand on the internet providers. I know I've been out in the Caribbean just after hurricanes. I've certainly seen what happens. I've observed how long it takes to get the infrastructure back up and running. And I know it can be very difficult for you. I know that the internet is intermittent. My advice as a teacher would be have a backup plan. Don't rely on it. If all you've got is using the internet to research something and the internet goes down, I know from experience that a whole learning experience, a whole lesson can be destroyed. And the only way that you can plan for that is to have a backup plan. You could download information before the lesson so that you've got that backup. Okay, we can't get on the internet. I downloaded this earlier. This information's from this place or that place, and we can use this to research this. You could use magazines, books, or video clips that you might have on record, that are about giving you information or evidence for what you want the students to research. You could ask them their experience. They might have seen something on the news yesterday or last night, and so you could use that as well. But it's just about preparing that backup, making sure that everything's working before the start of the lesson, planning the next lesson in advance so that if you have got intermittent internet, you can always switch to the next lesson. We don't have much equipment, so how can I do all the investigations? Demonstrating investigations is the last resort, but it's better than nothing. At least students see how equipment's used and how it's measured and how it works. And so demonstrations can be used quite successfully in place of an investigation. You could also use clips of people using it, but the best one I can come up with is have an investigation lesson after so many content lessons, and you could have a circus of activities, a circus of investigations. So if you've only got enough equipment to set up a test series circuit once, then have that as one activity in a carousel of investigations. The other investigation could be looking at I don't know, conductivity or whatever's in that series of lessons. Just put the investigation so that groups of children can move around from one investigation to the other to the other. So you're using whatever equipment that you've got. Also, are there alternatives? Could you use some alternative equipment? If the investigation says you use a Bunsen burner, do you need to use a Bunsen burner? Could you use a candle? Could you use a fuel burner rather than a Bunsen burner? I don't recall that in the resources we've just written in Mission Science that it ever asked for a Bunsen burner, but that's just an example. If it's asking for a complex piece of equipment and you haven't got it, then see if there's an alternative. Often in the teacher guide, we do state alternatives to use. We're at the end of this webinar now. I was told to finish in 40 minutes, and there we are, 40 minutes. And so I guess, unless you've got any questions, no one's written anything just yet, but unless you've got any questions, I guess I'll be handing over to Raina, and we'll be looking at all these places that you can make contact with us. So if you do come up with any questions or you've got any queries about these resources, please do get in touch, and I will do my best to answer it. And I know the team definitely will be able to answer any queries that you've got. So thank you so much for your time. I know that you're all in very strange but busy times at the moment. So thank you for using your time to visit me at this webinar, and I've thoroughly enjoyed it. I hope you have too. I hope you've got a lot from it. So thank you.
Perfect. Thank you so much, Debbie, as always. I hope the attendees felt that they learned a bit more about our resource. It is a fantastic resource and very popular in our Caribbean region as well. If you'd like to know more about the resource or our upcoming webinars, do feel free to contact us or check out our website for further information. And do follow us on social media as always as well. So thank you once again to Debbie. Thank you to our attendees, and we look forward to seeing you in an upcoming session soon. Take care. Bye.
Thank you. Bye.